Hello. Hello. Now my voice is clear. Okay. Look, the next chapter, that is polynomial. You did a few mistake in your math exam. Okay. One day I will discuss all that question. Okay. Look, the next chapter is polynomial. Do you know anything about polynomial?
An expression which has more than three terms.
An expression. Okay. Let's read the question. You have studied algebraic expression, their addition, subtraction, multiplication, and division in earlier classes. Here one term is coming, that is algebraic expression. Okay. Okay. Then we also know how to add algebraic expression, how to subtract algebraic expression, how to multiply algebraic expression, how to divide algebraic expression. That means in a previous class we have already completed this. You also have studied how to factorize some algebraic expression. You may recall the algebraic identities, like in your 8th class you know this is a identity. Identity means
Necessary.
necessary. Okay, x plus y square. So we know a plus b square is equal to nothing but a square plus 2ab plus b square. This is one of the identities. Like some x minus y square will be x square minus 2ab plus b square. And then another we know x square minus y square, that is nothing but x plus y all into x minus y. In our previous class, we learned about algebraic expression, their addition, subtraction, multiplication, and also some of the identities. It is telling about algebraic expression. There is a small difference between algebraic expression and polynomial. Okay, we will understand this. And they are used in factorization. In this chapter, we will start our study with a particular type of algebraic expression called polynomial. Look, polynomial is nothing but a special type of algebraic expression. A special
Type of
type of algebraic expression. Okay, and the terminology related to it. We shall also study the remainder theorem and factor theorem. Here we will learn two theorem. One is remainder theorem. One is a remainder theorem. One is a factor theorem. Okay. That means in our previous classes we completed algebraic expression and added their addition, subtraction, multiplication, and division, and we also know some of the identities. So in this chapter we are going to learn a special type of algebraic expression that is called polynomial. Okay, in this chapter we are going to learn. With this we learn two theorem. One is a remainder theorem, one is a factor theorem. Okay, and they are using the factorization of polynomial. How you use remainder theorem and factor theorem in our factorization of a polynomial, we will see how these two help. Okay, we shall study some more algebraic identities and their use in factorization and in evaluating some given expression. Irrespective of these three identities, we will learn several more identities in this chapter. Now what we learn? One is polynomial, number two is remainder theorem, number three is factor theorem, number four is how these two theorem help in factorization. Number four, some more identities, some more identities. Okay, then come to our chapter, polynomial in one variable. Let us begin by recalling that a variable is denoted by a symbol that can take any real value. What do you mean by variable? First thing, before starting polynomial in one variable, first we have to understand polynomial. Sorry, variable. Variable is denoted by a symbol. By symbol, then usually small a to small z, English alphabet. Okay. Variable is denoted by symbol, usually English alphabet. That can take any real value. Its value is not fixed. Value is not fixed. Suppose I am telling I have X rupees. I have X rupees. Do you know this X meaning? How much money we have?
Sir, not yet.
Okay. You understand? Variable means symbol. Generally we take symbol A to Z, English letter A to Z. Value is not fixed. Okay. For example, X, Y, Z. Okay. Notice that 2x, 3x, minus x, 1 upon 2x are algebraic expression. Look, all are the example of algebraic expression. And algebraic expression is nothing but mm, algebraic expression having variable, constant, and
Term. Term.
mathematical operation. Mathematical variable, you know, which is represented by English letter. Its value is not fixed. Constant, whose value is fixed, like 3, 5. Mathematical operations like plus, minus, into, divide. Group of this. Okay. Otherwise, we can say group of a term. Group of a term. It's nothing but algebraic expression. Like the 2x. 2x is a algebraic expression. 3x minus x minus 1 upon 2 all are called algebraic expression. Okay.
Okay, sir.
All these expressions are of the form a constant into x. Now suppose we want to write an expression which is a constant into a variable and we don't know what the constant is. In such cases we write the constant as a, b, c, etc. So the expression will be x. Look, actually the first thing is variable, you understand?
Yes.
Constant whose value fixed, whose value
Yes, sir. Fixed.
whose value fixed, like 3, 5. This value are fixed na? Then the next thing is term. The next thing is term. Term is nothing but a group of a variable or constant or product of a variable and a constant. Okay. Or a variable into variable. Term is nothing but a group of a variable, constant, variable into constant, variable into variable. Look, 2. 2 is a constant now.
Yes, sir.
It is also a term.
Yes, sir.
And 2, sorry, x is a variable now.
Yes, sir.
Okay, x, y, product of a variable now.
Yes, sir.
2x, variable into product now.
Yes, sir.
All are the example of a term. Okay, then algebraic expression is nothing but group of a terms with a mathematical operations. Mathematical
Alterations.
operations. Like 2x is a term, 3 is a term, this is a term, this is also a term, this is nothing but a mathematical operator. Mathematical
Okay.
operations. Okay.
Okay, sir.
However, there is a difference between a letter denoting a constant and a letter denoting a variable. The value of a constant remains the same throughout a particular situation. And here it is telling about constant. Constant value is fixed for a particular situation. The value of the constant don't change in a given problem, but the value of variable can be changing. Means variable value changing, constant value
Understand.
not changing. Not changing. These basic things you know in your previous class. Okay. Now consider a square of a three side. Suppose it is a square of a 3 unit. Means square having all the sides same na. What is it is a perimeter?
Three, 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 three.
4 into. Okay. Here each side is 3 unit, so it is a perimeter is 4 into 3, that is 12 unit. What will be the perimeter of each side of the square is 10 unit. Suppose instead of a 3 it will be 10 unit. So
What? 40.
40. In case the length of each side is x unit, the perimeter is given as, suppose instead of a 10, suppose it is x unit, it is x unit, it is x unit, it is x unit. Perimeter will be how much? 4 into x, 4x.
4x, yes, sir.
The perimeter is given by 4x unit, so the length of the side varies, the perimeter varies. Suppose, what does it mean? What does it mean? Suppose x value 1, your perimeter how much? 4. X value 2, perimeter how much? 8. X value 3, perimeter how much? 12. Look, when variable value is changing, perimeter is changing na? Constant remains same, constant remain same. But due to this variable, the perimeter is changing. Okay? Can you find the area of the square PQRS?
Which?
X, 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 P, Q, R, S. Can you able to find the area of this square?
No, sir.
X square na?
Okay. Okay.
Side square na?
Area.
Ah, area of the square equal to side square. Side value is x. So here x square. Okay.
Okay, sir.
X square is an algebraic expression. Look. X square is a algebraic expression. Algebraic expression is nothing but a group of terms. So x square is a term na? Term is nothing but group of a variable constant. Variable into constant. Constant into constant. Okay. Look, it is variable into variable because I can write x square as x into x na?
Yes, sir.
Variable into, sorry, variable into variable. This is na? You are also familiar with the other algebraic expression like 2x, x square plus 2x, x cube plus x cube minus x square 4x plus 7. Note that all the algebraic expression we have considered so far have only whole number as the exponent of the variable. Exponent of this form are called polynomial in one variable. Then what do you mean by polynomial? What do you mean by
All.
polynomial? It is nothing but algebraic expression. It is nothing but algebraic expression. But it is a power. But it is a power. Variable power. Variable power must be whole number. Must be
Whole number.
whole number. Don't say polynomial is a group of terms. No. Polynomial is nothing but algebraic expression. but it is a variable power must be whole number. Look, x power minus 2. Is it a algebraic expression? Yes, but it is not a polynomial. But it is not a.
Polynomial.
Why it is not a polynomial?
Oh,
Because it is a power is minus 2. Minus 2 is not a whole number.
okay.
X power 1 upon 2. Is it a expression? Yes. But is it a whole? Is it a polynomial? No, because its power is a fraction. Okay, you understand what I mean polynomial? Algebraic expression having the variable power whole number. Irrespective of the whole number, if anything you got from the power of the variable power, don't look constant power. Variable power, look. I am writing 7x plus 2 minus 2 power minus 2. Is it a polynomial? Yes. Why? Because here variable power is 1, na? 1 is a whole number. Don't look constant. Don't look constant power. Here it is telling only the look the variable power. Okay?
Okay, sir.
Root x. Is it a
Root.
expression?
Yes, sir.
Is it a polynomial?
No, sir.
Because I can write root x as a x power 1 upon 2. Okay?
Okay, sir.
Then polynomial in one variable. Polynomial in a,
One variable,
what does it mean? Polynomial in
one
one
variable.
variable. First thing, it should be polynomial means power,
X.
variable power must be whole number. Must be
Polynomial.
whole number. Then second thing, it should have a one variable. It should have a
One value.
one variable. What do you mean by one variable? Look, x
One.
square plus 3x plus 2. Don't look how many times the variable coming. One variable na x.
Same X.
So it is a polynomial. It is a
Polynomial.
polynomial with one variable. With one
Variable.
variable. Look, x square plus 3y. Is it a polynomial? Yes, because highest power of a variable, look, x power 2, y power 1. Is it a polynomial in one variable? No, because here two variable is there, x and y. Okay, means how many variable having in this chapter? All having same type. Look, y square y same na, y square, it should be same. Okay,
Okay, sir.
in the polynomial x square plus 2x, in the expression x square and 2x are called term, then how many terms are there in this expression? How many terms are there?
Two. Sorry, one.
Two
Term. Two.
term. One is x square, another is 2x. Two terms are there. The polynomial 3y square plus 5y plus 7. How many terms are there? Remember, terms are separated by plus and minus symbol. Okay,
Okay.
3. How many terms?
Three.
3 terms. 3y square, 5y, 7. Okay. Then look, this polynomial having 4 terms. Okay. Each term of a polynomial has a coefficient. Look, each term. Suppose I'm taking x square plus x square plus 7x minus 2. Coefficient is nothing but the constant number that multiply with the variable. Okay, look, how many terms are there? 4. How many terms are there? 4. One is minus x cube, one is 4x square, one is 7x, one is minus 2. Okay, if I asking the question coefficient of x cube, how much? Coefficient of x cube,
What's our coefficient of?
x cube. Hmm.
But
Here look, what is multiply with the x cube? minus 1.
Minus 1, okay, 1.
What is the coefficient of
4.
x square? 4.
4.
What is the coefficient of x? Coefficient of x equal to?
7.
Look, each term of the polynomial has coefficient. So in minus x cube plus 4x plus 7x minus 2, the coefficient of x cube is minus 1, the coefficient of x square is 4, the coefficient of x is 7, and minus 2 is the coefficient of x power 0. Here nothing is there. Here with 2, no variable there. But I can write x power 0, na? So now coefficient of x power 0.
2.
Okay. 2 is also a polynomial. In fact, 2 minus 5, 7, etc. are example of a constant polynomial. Wait. We learn types of. Just wait once. Then we will learn one term that is called degree. That is called the degree. Degree is nothing but highest power of the polynomial. Highest
Power of the polynomial.
power of the variable. Highest power of the variable in the polynomial. In the polynomial. It's called the degree. Look, x is cube plus 2x plus 3. Here highest power of a variable is how much?
X cube. So x to the power of 4.
Degree is 3. Degree is 3. Okay? You understand degree?
If you add x cube and 2x, it will be x power 4, right?
No. Don't add this. My question is highest power of the variable. You should look the highest power of a variable. Am I telling you to add the power?
No, sir.
Highest power. Then look. Based on this degree, we have different types of a polynomial. Different types of polynomial. Number one, cubic polynomial. Cubic polynomial means degree 3.
Three.
Degree of a variable 3. Degree of a variable 3. Like x cube plus 2x plus 9. Then quadratic polynomial.
4. Degree should be 4.
Quadratic polynomial degree 2. Degree
2.
2.
Then 4 square should be 30.
4 is biquadratic. 4 is biquadratic. Okay, biquadratic polynomial where degree equal to 4. Then linear polynomial. Linear polynomial degree 1. Degree 1. Then constant polynomial where degree equal to 0. Degree equal to 0. Suppose 2. 2 is a polynomial. Here the power of a variable x is 0 na, because I can write 2 power x into 0. Are you looking? Okay, this is the concept. Come to your book. 2 is also a polynomial. In fact, 2 minus 5, 7, etc. are example of a constant polynomial. Look, now I'm telling constant polynomial means constant polynomial. It is a type of polynomial in which degree equal to 0. Degree equal to
0.
degree of a variable equal to 0. Degree of a variable equal to 0. All the number, integer, whole number are example of a, all the constant value are the example of a constant polynomial. So how you can tell here the degree is 0? I can write 2 x power 0 na. Or x power 0 is nothing but 1 na. So here 2 into 1 it will be 2. So remember all the constant are the example of a constant polynomial. Constant polynomial means degree equal to 0. Okay. But the constant polynomial 0 is called 0 polynomial. Look. 0 is a constant polynomial. Yes, because I can write 0 as a 0 into x power 0. Here degree equal to how much?
Degree
0.
equals 0.
0. So degree equal to 0 means which type of polynomial? Constant polynomial? Which type of polynomial?
Constant.
Constant polynomial. 0 is also called 0 polynomial. Sir, what is the difference between 0 constant polynomial and 0 polynomial? Look, here in case of a 0 polynomial, we don't consider the degree. We don't consider the degree. Look, 0 polynomial means 0 into x power 0 equal to how much? 0.
Yes, sir.
0 into x power 1. How much? 0. 0 into x 0 into any number, it will give you 0, na?
Yes, sir.
So that is called 0 is a 0 polynomial. Remember, in the world only one number, only one constant, that is 0 polynomial, that is 0. Okay.
Okay.
So how many types of polynomial we complete? Cubic, then
Cubic,
quadratic,
quadratic, linear,
then linear,
con
constant,
0.
0. Cubic, degree 3, quadratic, degree 2, linear, degree 2, 1, constant, degree 0. Here only 0 is the number. Okay.
Okay.
Then come to, now consider algebraic expression such that x plus 1 upon x. Remember, okay, root x plus 3 cube root of a y plus a y square. Do you know? Do you know that you can write x plus 1 upon x plus 1 upon x as a x plus x inverse. Remember, don't keep variable on denominator. Okay, x plus x inverse by x power minus 1. Here the exponent of the second term, that is x inverse, is minus 1. Here exponent power of a second term x is minus 1 now.
Mm.
So it is not a whole number. It is minus 1 is a whole number. Whole number should start from 0 na.
Yes, sir.
So that's why this algebraic expression is not a polynomial.
Okay.
Okay. Root x. Root x I can write x power 1 upon 2 plus 3. Here look, the x power is 1 upon 2 na.
Yes,
It is not a whole number. So this expression is not a polynomial. Okay.
okay.
Then look, cube root of 3. Cube root of 3. It is nothing but y power 1 upon 3 plus y square. It is also not a polynomial. If the variable in a polynomial is x, we may denote the polynomial with p of x or q of x or r of x. So for example, we can write p of is nothing but, suppose there is a polynomial which having variable x, so I can write this p of x. P of x means there is a polynomial having x as the variable, equal to 2x square plus 5x minus 3. Okay. P of x is nothing but variable of a variable. There is a polynomial having x as it is a polynomial. Sorry, x as it is a variable. X as it is a
Variable.
variable. Just a minute. Wait. Just wait 1 second. Then q of x means it is nothing but we are writing polynomial of x. Okay. A polynomial can have any number of terms. Remember, a polynomial can having any number of terms. Look, Here how many terms are there?
4.
Like this it can have many terms. Okay.
Okay, sir.
Consider the polynomial 2x 2 5x cube minus 5x square u and u raised to the power 4. Do you see that all of these polynomial only one term? Polynomial having one term are called monomials. You know about monomials now?
Yes, sir.
Look, few seconds ago we learned type of a polynomial based on degree, based on a degree. Here we are learning types of a polynomial, types of a
Polynomial.
based on a based on a
Degree.
no based on a term, based on a term.
Term.
If you want term, monomial. If you want term,
Monomial.
monomial. Two terms, binomial. Three term,
Monomial.
trinomials. And more than three, all are called polynomials, but all more than three polynomial.
Okay, sir.
By means two. Similarly, polynomial having only three term are called trinomials. Some example. Look, these are the example of a. Look here, root two. Don't think it is. I can write 2 power 1 upon 2. You can write, but it is not variable term. It is the constant term. Don't look the power of a constant. Only look the power of a variable. Is it positive? Then it is a polynomial. Okay. Now look the polynomial px, polynomial of ax, 3x power 7 minus 4x raised to the power 6 plus x plus 9. What is the term with the highest power x? Look, 3x raised to the power 7 minus 4x raised to the power 6 plus x plus 9. How many terms are there?
3. 4. 4.
4 terms. The question is, what is the term with the highest power of x?
6. 4. 4 x to 6.
3x to the power 7, na?
7. I thought 2, sir.
That is 7. Similarly, in the polynomial 5y power 6 minus 4y raised to the power 2 or 4 square minus 6. Here, what is the highest power of y?
4. 5 by 6.
6. We call the highest power of a variable in a polynomial as the degree of the polynomial. We already completed this. The highest power is called a degree. Highest power is called a
Degree.
highest power is called a
Degree.
degree. So the degree of a polynomial 3x raised to the power 7 minus 4x raised to the power 6 plus x plus 9 is 7. Look here, what is the degree of this polynomial? Look the highest power
7. 5.
7.
7.
7. Okay, the degree of a non-zero constant polynomial is 0. The degree of a constant polynomial, we already completed this, no need to revise it. Okay, then look example 1. Example
1.
find the degree of each of the following in the given. Okay, x raised to the power 5 minus x raised to the power 4 plus 3. Tell me, what is the degree of this polynomial?
X to the power 5.
Only 5. Why are you telling me x raised to the power 5? Degree means highest power.
Okay, sir.
Then in the second equation, 2 minus y square minus y cube plus 2y raised to the power 8. What is the highest? What is the degree?
8.
2. What is the degree?
0.
0, because I can write it as x raised to the power 0. Now you observe the polynomial px of a 4x plus 5. qy equal to 2y, rt equal to, look, px of a 4x plus 5. Pf of x means there is a polynomial that having variable as x. Okay. q of y means there is a polynomial that having y as it is a variable. R of t means there is a polynomial which having t as it is a variable. Okay.
Yes.
And s of u is nothing but there is a polynomial having u as it is a variable. Do you see anything common among all of them? Do you see anything common?
By
In all these things, degree is how much?
0, by 1, 1.
1. So a polynomial of degree 1 is called linear polynomial. We already completed this. Okay? Linear polynomial. Now try find a linear polynomial in x with 3 terms. Now your book is telling you have to find linear polynomial with 3 terms.
Okay. 3x plus 4y.
It is a linear equation. So linear polynomial in 3 terms. Okay. You would not be able to find it because a linear polynomial in x can have at most 2 terms. If you look, if I am telling find 3 terms of this polynomial, you cannot ever, because here x power is 1 na? And your variable should be x. Look, if you don't change the variable, then how can you change the power? If the, how can you change the term? Okay,
Okay.
if you, here I am changing the term, that's why I am able to writing. But here I am already defining na कि there is a polynomial of x variable. That means we should write the polynomial that should have variable x. So for this we cannot able to write the polynomial with term. The question is, if I am giving you p of x means polynomial of x equal to 4x plus 5 and telling you find three term of this polynomial of this,
Polynomial.
it's impossible. It is
Simple.
impossible. So any linear polynomial in x will be the form of that means that's why telling is linear polynomial general form. Linear polynomial
General form.
general form it is always in the form of ax plus b, ax plus b. There will be no third term. X plus b where a does not equal to 0. A does not equal to
0.
0. Why? Suppose there is a equation ax plus b. Okay. Sorry, ax plus 3. Okay. Here a means coefficient of x plus b means constant. Look, suppose a value I am putting 0. Then it is converted into 3. 3 is not a linear polynomial. 3 is a constant polynomial. Are you looking?
Yes, sir.
Remember the general form of a linear polynomial will be ax plus b where ax is a variable, where x is a variable, a is a coefficient, b is a constant, and a does not equal to 0. A does not equal to
0.
0. Then come to quadratic polynomial. Quadratic
Polynomial.
highest power how much? Degree how much? Degree of variable 2. Degree is 2.
Okay.
Okay, some example of a quadratic polynomial is 5 minus y square, 4y plus 5y square, then 6 minus y square. Here degree 2, degree 2, degree 2. That means all are called quadratic polynomial. Can you write a quadratic polynomial in one variable with 4 different terms? You have to write a quadratic polynomial with one variable means should be one variable. Okay. The question is, suppose I am giving you one quadratic polynomial. y square minus y plus 6. It is a quadratic polynomial. Hello.
Yes, sir.
And it is quadratic polynomial in one variable.
Mm.
That is why can you able to write a quadratic polynomial in one variable with 4 terms? Here 3 terms are there, na?
Yes, sir.
Can you able to write a quadratic polynomial with 4 terms?
Yes, sir. Yes, sir.
How? Tell me.
Sir, y cube plus y y square.
If you change the y cube, is it a quadratic polynomial?
No, sir. Okay, can't, sir.
Oh, we can't. That means it is a general form is ax square plus bx plus c. The general form of
Two y squares, right, sir?
just wait. I'm telling. The general form is ax square plus bx plus c. Here x square is nothing but variable. X is nothing but variable. A is the coefficient of a variable. Here A is the coefficient of a variable. C is nothing but constant. Okay.
Okay,
And
sir.
here A does not equal to 0. B also does not equal to not 0. Sorry, B can be 0, but A never be 0. The meaning is the x square coefficient should not be 0. Look, I'm taking one example. You can say, sir, it is not in the form of ax square plus bx plus c, na? Where is the bx term? Where is the bx term? I can write it as y square plus 5. This is the x square term. This is the constant term. Sir, where is the bx term? It is called pure quadratic polynomial. Pure
Quadratic
quadratic polynomial. And here is no, here x term is not there. But I can write na. What is the problem? 0x. Look, 0x is nothing but 0 na.
Yes, sir.
Okay. We can convert a pure quadratic polynomial into its general form by using their x term, and the coefficient of x term should be 0. Okay.
Okay, sir.
And the next condition, in a quadratic polynomial, it is general form. This a should not be 0. This a should not be 0.
Yes.
Why, sir? If I am writing 0x square plus 3x plus c, here 0x square is nothing but 0 na.
Mm.
So look, it now highest degree is 1 na. It is converted into linear polynomial. That's why a power should not be 0. Okay.
Okay, sir.
Then we have already complete cubic polynomial.
Polynomial.
Cubic polynomial is nothing but degree 3. And general form ax cube plus bx square plus cx plus d. Okay. And a should not be 0. A should not be
Zero.
0. Example, 2x cube plus 3x square plus 4x plus 3. Look, highest power is 3 na.
Yes, sir.
Sometime you may got 3x cube plus 3. It is also a cubic polynomial. You can say, sir, it is not in it is a general form. You can write na 3x square plus 0x square plus 0x plus 3. Now you look. Okay.
Okay, sir.
Then now you have seen with a polynomial for degree 1, 2, 3. Okay.
Okay, sir.
Can you write down a polynomial in one variable of a degree n? Any natural number n. You have to write now a polynomial who having degree n, means highest power is n. A polynomial in one variable x, our degree n is an expression of the form. How it is expression? A n x power n plus a n minus 1 x power n minus 1 plus a1 x plus a0. Sir, what does it means? Here x is nothing but your variable. X is nothing but your
variable.
suppose I am writing, look, 7x square plus 2x 5 plus 3x 4 plus 7x plus 3. Sir, it is not in it is general form. You have to write, look, took highest power. Here n is equal to 5 na?
Yes, sir.
Took highest power as the first term. Took highest power as the first term. That means here n is nothing but highest power. Highest
Over.
power. Then 3x plus 4. Then 3x plus 3x raised to the power 4. That means n minus 1 term. Are you understand?
Yes, sir.
This is the concept. This is the concept. In a particular a0, okay, we get the zeroth polynomial which is denoted by 0. What is the degree of the zero polynomial? The degree of the zero polynomial is not defined. If someone asks the question, what is the degree of a cubic polynomial?
The degree should be
3. Quadratic?
degree should be 2.
Linear?
Degree 1.
Constant?
Degree 0.
0?
0.
No,
Non 0.
not defined. Non-defined degree?
Oh,
Not defined. Sir, why, sir? Why degree is not defined? Look, if I am writing 1, sorry, 0. 0 into x power 0 equal to 0.
yes, sir.
0 into I can write x power 1. This is also 0. 0 into x power 0 2 equal to 0. 0 into x power n also 0. Can you define here 0? What is the degree? Because it's taking all degree na, 0 1 2 3 n. Okay,
Okay, sir.
the 0 polynomial degree is not defined. Look, like this, here we are focusing polynomial having one variable. Here you look, it is also a polynomial na?
Yes, sir.
It is which type of polynomial? Quadratic. Quadratic. But this polynomial having more than one variable. More than
One variable.
one. It is a quadratic polynomial but having more than one variable. Here x is a variable, y is a variable, z is a variable. Okay.
Okay, sir.
Where variable x, y and z is a polynomial 3 variable. Similarly, p square q raised to the power 10 plus r. It is also a polynomial but having three variable. Having 3 variable. But our chapter concept is learning one variable.
Okay, sir.
The look exercise 2.1. Which of the following expression are polynomial in one variable and which are not? You have to find polynomial in one variable. Polynomial in one variable means how many condition? Look, first power should be whole number. Power should be
Whole number.
then variable should be one. Variable should be one.
1.
Power of a variable. Power of a variable. Look, first equation. Polynomial in one variable.
Yes, sir.
Yes, because highest power of a variable is sorry, power of a variable is 2 and 1. So it is a polynomial. Which type of polynomial? One polynomial having one
Variable.
variable. So one here y square plus root 2.
Poly. Sir,
Yeah, tell me.
not a polynomial.
Why are you looking to the constant term? Tell me. Look the variable term. If variable term is having power as a whole number, then it is a polynomial. Don't look constant term. Here 2 is a constant term. Na? The formula is only for variable, not for constant.
Okay, sir.
3 root t plus
T root 2.
uh,
Non polynomial.
Because here the problem is here. This root t I can write 1 upon 2. Okay.
Okay, sir.
Always focus on variable. Suppose tell me, is it a polynomial? Root 2t.
No, no, sir.
Yes, yeah. Look the polynomial power. Why are you looking your coefficient? Okay, only for power. Don't look coefficient. Power of a variable. Power of a variable should be whole number. Should be
Whole number.
whole number. If power of a variable, here you look power of a variable. T power is 1, na? It is whole number, na? Then why are you looking about coefficient? One thing, don't look coefficient. Do not look
Coefficient.
coefficient, and don't look
Power.
constant term. Don't look constant term. Y plus 2 upon y. Don't put your variable in denominator. It will be 2y power minus 1.
Okay, sir.
So here y power minus 1 is a not a whole number, so it is not a polynomial.
Okay, sir.
Here x power 10 plus y power 3 plus t power 50, t raised to the power 50. Is it a polynomial?
Yes, sir.
Yes, because all having power as a whole number. Write the coefficient of x square.
X square.
Each of the following. In the first case, x square coefficient is
Sir, 2. 1, sir.
1. In this, x square
1.
minus 1.
Oh, sorry. Y minus 1.
Here
Square. X by 2.
pi by 2.
Sir.
This is not x, this is pi.
Okay.
Here
Root 2.
x square, we are finding x square. Here there is no x square term, so it will be 0.
Okay, sir.
Give an example of a binomial for degree 35. Binomial means two terms. This is the example of a binomial. Monomial of a degree 100. Okay.
Okay.
Then write the degree of each of the following. Here degree means highest power. Degree
I can't see numbers, sir.
3.
3.
Here
Sir. 2.
2. Here
1, sir.
1.
0.
Constant having 0. Here 0 degree. Classify the following as a linear, quadratic and cubic polynomial. Linear means degree 1. Quadratic means degree 2. Cubic means degree 3. Look here, highest power 2, so it comes under quadratic. Here 3 cubic, here 2 quadratic, here 1 linear, 1 linear, 2 quadratic, cubic. Okay.